Have you ever dreamed of traveling through time to witness history's greatest moments? Imagine stepping back to the Jurassic period to walk among towering dinosaurs, maybe even daring to ride a T-Rex. Or venturing into ancient Egypt to uncover the secrets of the pyramids and finally solve the mystery of whether aliens had a hand in their construction. What if you could leap forward into the future to see if artificial intelligence has truly surpassed human capabilities? The possibilities seem endless with a time machine. But here's the big question. Is time travel even possible? Can we really break free from the present and journey into the past or future? In this video, we'll explore the fascinating science and mind-bending theories behind time travel. So buckle up, relax, and get ready for an extraordinary journey through time. Time travel is the idea of moving through time, much like we move through space. Instead of being limited to experiencing only the present, time travel allows us to visit the past or leap into the future. Right now, as you're watching this video, you are technically time traveling minus 1 second per second. Every moment that passes, you're moving forward in time, just like everyone else, experiencing the flow of time in real time. But imagine being able to break free from the usual flow of time. Time travel means the ability to jump to different points in time, whether that's traveling backward to witness historical events, exploring the future to see what lies ahead, or even speeding up time to experience an entire year in a moment. It's the possibility of moving faster or slower through time than we normally can, which opens up exciting, limitless possibilities. To fully understand time travel, we need to dive into the science of how time actually works. And to do that, we need to turn to one of the most groundbreaking theories in physics, Albert Einstein's theory of relativity. This theory tells us something quite strange. Time isn't constant. It can actually change depending on how fast you're moving. This phenomenon is called time dilation, and it's one of the key ideas that underpins the concept of time travel. To grasp this concept, imagine two people. One is standing still on Earth, and the other is zooming through space in a spaceship moving near the speed of light. According to Einstein's theory, time behaves completely differently for each of them. For the person standing still on Earth, time moves normally, 1 second per second, like we experience every day. But for the astronaut in the spaceship, time slows down. The faster the astronaut moves through space, the slower time passes for them relative to someone who is standing still on Earth. This isn't just a theory. This concept has been experimentally verified in the real world. One of the most famous experiments was conducted with atomic clocks. These highly precise clocks were placed on airplanes, and after flying around the Earth, they were compared to clocks that stayed on the ground. When the clocks were compared, the ones on the planes showed that they had ticked slower than the ones on the ground. This is exactly what Einstein predicted, proving that time really does slow down for objects moving at high speeds. With time dilation experimentally verified, the next question is, can we harness this phenomenon to travel through time? Moving forward in time is more than just a theoretical idea. It's grounded in science. For example, if you were able to travel near the speed of light, time would slow down for you. In essence, you'd leap forward into the future while the rest of the world aged more quickly. But what about traveling backward in time? That's where things get tricky. While traveling into the future is supported by the principles of physics, moving to the past is far more speculative and surrounded by controversy. Theories exist, but none have been proven or demonstrated. One popular theory involves wormholes, hypothetical tunnels through space-time that could connect two distant points in time. They serve as shortcuts that might allow you to travel between eras. If wormholes exist and could be stabilized, they might theoretically enable backward time travel. However, wormholes remain purely theoretical. None have been observed, and even if they exist, we have no idea how to create or navigate them safely. Another intriguing theory involves faster-than-light travel. If you could somehow exceed light speed, which is around 300,000 kilometers per second, it might allow you to move backward in time. For instance, to reach the Jurassic era, which is about 150 million years ago, You'd need to travel at least 10 times the speed of light, and even then, it would take you 15 million years of time travel to arrive there. So, riding a T-Rex still remains firmly in the realm of science fiction. Even if backward time travel were possible, it would come with a host of perplexing challenges, especially time paradoxes. These paradoxes are not just philosophical puzzles. They represent potential violations of the fundamental rules of cause and effect that govern our universe. One of the most well-known paradoxes is the grandfather paradox. Imagine you traveled back in time and, either accidentally or intentionally, prevented your grandfather from meeting your grandmother. If that happened, your parents, and by extension, you would never have been born. But if you were never born, how could you have traveled back in time in the first place? This creates a logical inconsistency where your actions in the past erase your ability to perform those very actions. It's a paradox that defies the linear sequence of cause and effect. Another puzzling idea is the bootstrap paradox, also known as a causal loop. This occurs when an object, piece of information, or even a person exists in the past solely because it was brought there from the future. For example, imagine someone travels back in time and gives Einstein the theory of relativity. If Einstein didn't discover it himself, but the theory still exists, where did it originally come from? This creates a loop with no clear beginning, challenging our understanding of how events unfold. These paradoxes don't just raise questions. They challenge the basic rules of how the universe operates. At the heart of the issue is causality, the principle that every effect must have a cause that precedes it. Causality ensures events happen in a logical sequence, where one thing leads to another. If time travel to the past were possible, it could disrupt this natural order, creating contradictions that might throw the timeline into chaos. While time paradoxes present significant challenges to the concept of traveling to the past, scientists have proposed intriguing theories to address these issues. These ideas explore possible ways the timeline could remain constant despite changes, or how alternate realities might emerge. One such theory is the Novikov self-consistency principle. This theory suggests that the timeline would correct itself to avoid paradoxes. If you tried to stop your grandparents from meeting, something would prevent you from succeeding. Maybe your time machine breaks down, or another event gets in the way. According to this idea, any action you take in the past would already fit into the timeline, ensuring consistency. However, this principle is just a theory and hasn't been proven. Another explanation comes from the many worlds theory in quantum mechanics. This theory suggests that every time something happens, the universe splits into multiple parallel timelines. If you traveled back in time and changed something, you wouldn't affect your original timeline. Instead, you'd create a new, alternate version of reality. While this avoids paradoxes, it raises new questions. Could these alternate timelines ever interact? Or would they remain completely separate? Because of these paradoxes and the complexities they introduce, many scientists argue that time travel to the past is likely impossible. Even if we could one day manipulate space-time in ways we currently can't imagine, the fundamental rules of causality might act as an unbreakable barrier, ensuring that the past remains untouchable. For now, time travel into the past is a fascinating idea that stretches the limits of imagination. It fuels science fiction and inspires deep scientific inquiry, but it remains firmly in the realm of theoretical speculation, constrained by the laws of the universe as we currently understand them. Thanks for joining us on this journey through the past, present, and future. If you enjoyed exploring interesting stories with us, don't forget to hit that subscribe button. What topics do you want us to dive into next? Let us know in the comments. Join us as we get animated about science here at Animated Science.